go into question and answer. Data sync. Data sync, as the name implies, is a data storage that is designed for a variety of sources. Some keywords there. What data storage? That tells us that data sync actually stores your data, and then the data that is stored comes from a variety of sources. We'll talk more on details on all this. Then also it can store raw data or process data. Raw data is data that you have in the original format, not yet processed. The end product of your raw data is what is going to give you information. So the storage will be for short term or for a longer period. Also, data sync typically is used to store your data for future processing, analysis, and some of the content is So now, we're going to why data sync so important. You know, there have been some trends and then projection in terms of the volume of data that is being generated in the world today, right? As at, they say in the year, by the year 2025, the world will have generated the data that is around 180 zettabytes, right? If you look at that, you might imagine how big is that? 1,000 exabytes is what gives you one zettabyte, right? So if you break it down, then you talk of 1 million petabytes is what is going to give you 1 zettabyte. You talk of 1 billion terabytes is what is going to give you 1 zettabyte. So this data is so huge that it's being delivered. They say on a daily basis in the world today, they are generating data that is around 330 petabytes. Right? So this tells you that this data that is being generated comes from different industries, and they hold vital information which needs to be properly stored. By the time you process the data, it's going to give you so much opportunity. It helps companies to be able to achieve their goals and objectives in terms of profitability. So now, we now look at So the question again is what makes data sync to be so important? You know, we have said that data sync is where you store your data, right? So now, one of the key importance of your data sync is that they provide a secure and reliable way to store your data. Your data must be secured in terms of storage, because any loss in the data that is stored there can have very serious implications to a company. Take for instance a bank that a customer that has history of their transactions in the bank, and then you now go to that bank that you need access to that data and they tell you that the data is not available. It will lead to court case, and you can imagine the implications. So when data is lost or not properly managed or stored, it can cause that will cause company to shut down or to stop operation. So secondly is that it's a business enablement. It's in the sense that enablement, in the sense that it helps you, the data that you stored, you can run some reports, right, your business intelligence against it. It will help the company to be able to determine how it is actually performing in terms of profitability. It helps you to be able to come up with some products that will help you identify the ones that you have, how are they doing. You look at the distribution of your customers and then the product that you have. So from the report that you generate, it's going to help that company to be able to do better. Then it ensures that data availability and retrieval is easily available. With data storage, you can keep your data for historical access. There are some compliance implications that in telco, right, we have what you have compliance requirements that they come and make requirements. They want to see some of your reports, right? They want to see some of your data. So just like where data warehouse environment, you have aggregated data and then you run heavy queries against that environment. So that's more like it. So they are more concerned with historical data. That's kind of data that you have in your data warehouse environment. Then once added, the data doesn't change often. It's only in an OLTP environment, which is where you have the relational databases, that you have your data that are frequently changing. That's why it's called OLTP, Online Transaction Processing. So this one is more designed for analysis of business operations. So when you load your data into this environment, you run your business intelligence reports against it, and then it helps business to know how they are doing. Then also, it is optimized for complex and predictable queries. So within the data environment, you have very complex joins, right, that you run against that environment, unlike OLTP, operational databases. The queries you run there are quite simple and fast because of the size of data that you have them managed. Usually, this is usually larger. So it is designed for online analytical processing. Then also we move to MOLAP engines. So these are the types of, or the categories of data streams we are talking of. So MOLAP engine, it is more traditional OLAP, right? OLAP is more like your data warehouse environment, online analytical processing. So this one is MOLAP. It is more traditional to that one, right? Because it's with this environment, you have an aggregation of your source data, right, with aggregated calculation. So it presents it to you in form of multi-dimensional format, right? So what is the benefit of this? It is the fastest option of data retrieval, right? But with the caveat that you are going to need more storage to be able to store your data here. Then also it is more appropriate for queues. Queues is a way of storing your data, right, that is very large under OLAP. So with frequent use and the necessity of rapid response. So you have faster response with this MOLAP. You go to data lakes. There are some, for any new solution that you have, most times they come to make life better for you over existing one, right? Or maybe to solve some problem that an existing solution could not make available. So data lakes, there are some things that are peculiar. Your data lakes are more usually designed for processing structured data, right? So data you have for sure when handling unstructured data. Examples of unstructured data, you have like videos, right? Image related, like your text, right? Music, all these are unstructured data. So, and this is required for data science and machine learning type of workloads. So, this is where data lake comes in. So, data lakes are usually highly scalable. Scalability here implies that when the need arises for you to grow your workload, in terms of maybe you need to add more storage, right? It is very easy with a data lake. And it is flexible in storing various types of data. You have types of data like structured data, semi-structured data, and then unstructured data. The structured data is usually in form of table format, right? We all knew Excel sheets. It has rows and columns. So also it is adept at handling data in batches as well as in stream. Your stream-based data are usually very short, right? And then very fast. And then the rate at which they are being generated is also pretty fast. And that is why when you are loading your stream data, you need processing requirements, you need application types or solutions. Your data pipeline must be designed that the rate at which the data is being picked is as soon as the data is being generated. That is where you have the real-time processing. But for batch-based processing, that one usually runs at batches, at scheduled intervals. You can see at 10 minutes. That's where you want it to pick data from source and then to be loaded to the target medium. It could be 10 minutes, 30 minutes, 1 hour. It can even be monthly or weekly. So those are the peculiarities with your batch type of loading. So then a data lake offers more storage options. It has more complexity and has different of use cases. So for all these, there are different use cases that you need to consider before you adopt them as your data sync solution. For data warehouse, that is what vertical scalability means. But if it is an horizontal scalability environment, right, you will conveniently be able to get another server, just hash to it, and then your workload will conveniently be distributed. transparently in a horizontally scalable environment. So, for your data warehouse, it scales horizontally by adding more resources to a cluster. Then for data lake, the same thing, data lake too can scale horizontally. So what is the recommendation in this scenario? Is your data needs are likely to grow over time, right? Because what? Because of the horizontal scalability of your data lake, right? It will be recommended that you adopt that. If it is going to grow over time and then it's unstructured data, those are the factors that you need to look at to pick a data lake. Then cost, just as we know, for any implementation you want to do, it has lots of cost implications. So databases typically is more cost effective for transactional workloads. Transactional workloads are OLTP based, right? Which are transactional, like short insert, updates, queries like that. For data warehouse, it will be more expensive than deploying the data warehouse solution, especially for large-scale analytic workloads. Data lake pool is also cost-effective for storing huge amounts of raw data because of what? Because the storage that it uses are usually not highly priced. So, however, processing could cost more. Query performance is the fourth factor that we are looking at when you are trying to choose technologies for your data set. Database it is enhanced for quick, low latency queries on structured data. This is an attribute of an OLTP environment. Data warehouse is perfect for complex analytic queries on large data sets. That is why you have aggregated data and you run your reports against it. You do lots of joins against on the data to generate reports against that platform. So it is very perfect for that kind of operation, and that will not work well in a database environment. Data lake also, due to its schema on redesign, it can be slower for ad hoc queries. So ad hoc queries, you don't run it. Ad hoc queries are good for database environment, but there's just managing enormous amounts of data. That is an attribute of data lake. We are talking about that. So what's the recommendation? If your data requires complex analysis and reporting, which we all need, but if we ask, I'm sure we'll all be able to answer that question too, that yes, it is data warehouse, there will be an option for that. So we look at data size. So if your data size is very small to medium size, then naturally it will go to database. For database, it's very ideal for applications that require real-time data processing, high transactional throughput, and data consistency. We are talking of data consistency. That is to say that your data should be consistent across. When an update is made, it is the update that user A is seeing that user B too will be seeing. Typical applications, your transaction system, transactional based applications will run there, content management systems, and then inventory management application will be suited for database environment. MOLAP is suited for data mining or other business intelligence applications, also complex analytical calculations and predictive scenarios. You want to be able to make some predictions. It will be good for MOLAP, as well as different reporting functions for financial analysis, budgeting, and forecast planning. Use case for data warehouse. It is suitable for organizations that require consolidated view. We have said that data warehouse is also designed RDB stores structured data, right? So for consolidated view of structured data from multiple sources, right? For what? For reporting, analytics, and business intelligence to enable your business decision. For data lakes, they are well suited for organizations that need to store and process large volumes of diverse data. Diverse data, different data types. Is it structured? Is it unstructured? Is it semi-structured? You can store them for exploratory analysis, machine learning, and then data mining or science research. This is very good for that. So, we go to the future of data warehousing and analytics. You know, the other time when I was talking, I made us to realize that you have your data warehouse separate, right, as a separate entity. You also have your data lake as a separate entity. So we will expect that in the future, because you have opportunity of being able to access data that you stored in the two environments, because they are different. Data warehouse is structured data, right? But your data lake can store any kind of data. In terms of scalability, is better off, right? Also, use cases like machine learning, data science, you store them in your data lake. You will now have is more benefit to the business that I want to be able to access the data I have in these two mediums, right? I want to be able to access them at the same time, and accessing two must be very fast. So that is what data lake house, what it gives you. So we will expect that over time there will be more playing into this area of data sync, right? Because of the opportunity that it gives us. So it's going to be more like the modern data warehouse, because it gives you a layer that aggregates the data you have in the two mediums, right? And then so that is what you have. Let's look at the architecture of your data lake. So this is it. You see that what you have here is more like your data warehouse, right? Structured data. So you have your batch data loaded, you have your streaming data loaded, and then you have, these are the sources where the data is coming from. OLTP, which is a database, right? CRM, ERP, these are different categories of data that will be coming from different units of your organization. Then you have SaaS as an application. So you load them, this as streaming and batch, you load them into your data warehouse, right? And also you have the data lakes. These are the kind of data that you have there, right? Your sensors, audio, video, images. These are unstructured data, whether in batch format or in streaming format. You put them in your data lake. So on top of it, you can see the integration in between these different data sources, right? So this is your storage layer. So on top of it, you have a shared catalog that helps you to be able to see what is there. With this integration, it makes it easy to be able to see what you have within the two areas. So that's the catalog layer. On top of it, you now have your processing layer, SQL-based processing, big data processing, read near real time. So that is, on top of that, you now put your consumption data, which has your business intelligence, your machine learning, your interactive queries. All of them will be pointing. So instead of you now having access to just data warehouse or data lakes individually, this architecture even makes access to your data much easy in terms of speed, right? It's quite faster. So it's like you are getting two opportunities, right? From you aggregate opportunities, and the access to it is quite easy for you. So what's the bottom line here? Data lake will surely wither the existing data architecture. That is what is expected to become more popular over time, right? It is a low-cost solution with open and direct access, extended machine learning support, and state-of-the-art. In terms of performance, you have a state-of-the-art performance from that architecture. Then it's going to help organizations to dramatically improve their productivity, right, and fetch informed business insight efficiently. So this is the end of the presentation. It's time for us to go our questions. Yeah.
Does it mean that companies like Netflix, Spotify, who do a lot of video and data lakes, based on what you shared with us.
Yeah.
Okay. Yeah. Thank you so much for that presentation. My name is Kelvin. I'm a big data engineer. And my question is around, I know Bluechips, you work with clients, and I want to understand when you meet a client that has legacy infrastructure. So think about the old days, Informatica, SSIS, for their ETL pipelines and all that. And then for these people, they don't have any technical competence with this, the new toolings, like the lakehouse and all that. How would you go about it? Are you going to stay with your legacy solution and then help them to develop people with expertise around where they are? Or you are going to say, hey, let's move on from here. And then you know the implication of that is when you change stuff, you might really put them in trouble because they don't have the technical competence in-house to handle that. My second question would be around your choice with regards to ETL and ELT. I mean, not generally what the industry will say, but from the perspective of you implementing solutions at Bluechip Technology.
Yeah, thanks for the question. The first one, in terms of training and the existing solution that a customer has. So usually we come around, right, to do an analysis of the kind of solution that we currently have, right, and we make recommendation, we develop, we come up with our own, because we have done implementation, we have host of customers that we have implemented this data warehouse solution for, right, and we use current technologies, right, that makes the aggregation or collection of your data from different sources to your data sync and then deploy the necessary business intelligence solutions to it. So we come forward with presentation. By the time we do it, you obviously will be convinced that yes, this is a better solution than what you currently have in, right? Then looking at it from the area of training, we do post-implementation training. But at the point of even doing the implementation, we carry along the existing resources, right? We work together, and then when it is completed, the customer can either choose to say, we want to be the one to manage this environment by ourselves. Maybe you provide L3 support, or we want to outsource even the management to Bluechip. These options are available, but what is more important is we do post-implementation training, and even at the point of implementation, we work with the existing staff. Yeah. So the second question.
It's about whether to go with the ETL approach.
ETL is the old concept,
Okay.
right? And it is what ELT has come to solve. But the old concept of ETL has challenge in terms of being able to manage, but it's not designed for managing heavy data. You understand why? Because at the point of data that is coming, as data is coming, it will be doing transformation at the same time. You understand? It is when it completes the transformation that is now noticed to the final data sync, when you now deploy your business intelligence against it. But with the concept of ELT, it will just be bringing the data straight into your data sync environment or your data repository, which is when the data is already landed. So in terms of speed, you don't have any delay. And you know we are talking of big data. In the days of using the ETL, right, data that you manage is quite sizable. So as the data is coming, you do the transformation on top of it. So you won't feel it that, well, since the data is not more, you won't look at speed. But when the data is so huge, that approach cannot work to manage big data, and that is what ELT has come to solve. So we have to round up at this point so that the next speaker can take over. Thanks so much.